Hello, everybody. Let me introduce myself first. My name is Gregor Pipan, and together with my colleague Petra, we will be hosting you at today's webinar. I suggest to just wait for a few moments before everybody joins in, because we have a lot of registrants for this webinar. Okay, let's start. So let me first share some technical information regarding the webinar. So the session is being recorded, and we will share the recording with you later on. You're welcome to post questions during the webinar. For this purpose, you have a section in control panel of the webinar where you can post the questions, and we will answer them at the end of the webinar so that we don't interrupt the webinar in the mid of the session. There are many of you who don't know us yet, so I would like to take a moment to shortly present our company and what we do. Just a few words. So we have been around for a long time. We have more than 30 years of experience in the field of digitalization of the built environment. We are international software company with offices all over the Europe and partners network all over the world. We're very much involved in the development of BIM and are part of building smart organizations, and we contribute to the development of the standards in the field of digital infrastructure design. We're also members of Building Smart Germany and Building Smart Slovenia. About what we do, with our CGS Labs Civil Solutions cover three main civil engineering fields. These are software solutions for road infrastructure design and maintenance, for railway design and maintenance, and then we have a solution also for river and channel engineering works design. Today we will focus mostly on the road design department and railway design. In the road design we have three products. The one that we will talk about today is PLATEIA, which is a kind of complete solution for road design and maintenance. And then we have also two additional products that are for traffic sign and road marking design. This is AutoSign, and the smaller solution AutoPath, which is intended for sweat pattern analysis and vehicle turning simulation. In the railway design, we have FERROVIA, which is for design as well as for rail track maintenance rehabilitation. And already mentioned for river engineering works, we have Aquaterra. Today, the topic will be 3D geological model, designing of the 3D geological BIM model for the purpose of roadway design and railway design. And all the features that you will see in the technical part of presentation are also part of PLATEIA software, which is our main software for the road design, which is a BIM solution. And as mentioned before, in the FERROVIA software, which is BIM solutions for railway design and rail track maintenance. So features presented are included in those two solutions and can be used for that purpose. both software have extensive users database. Here are just some of few. Sorry, just a second. I have problem with the sound. Okay, both software have international users, and here are just some of the references for the software. Now, without further ado, I would like to give into the hands of my experienced colleague Petra Tichole, who will show you how to actually design the 3D model, 3D BIM geological model. So, Petra, please, the floor is yours.
Thank you, Gregor, for this introduction. And hello to everyone. I hope you are all having a great day. My name is Petra, and I am a technical support engineer at CGS Labs. I'm very delighted to have you join me in this webinar today. In this session, we will cover the basic of designing a 3D BIM geological model for road and railway projects. Last year, we did our best to come in contact with customers, and we found out that many users do not know that they can insert multiple terrains in the profile and cross-sections views. In addition, we have also noticed a lack of knowledge in the creation of cross-sections and in planimetry, which is very important since both the quantity takeoff and the drawing of a 3D model are based on planimetry quantities. That's why we decided to hold a webinar where I will try to address all problems and complications you might be facing. I'm going to do this by working through a sort of a typical workflow that I use, and I'm going to call out the new features. In addition, I will share some interesting tips and tricks that you can help you to be faster and more successful during the design process. I want to mention also that both new and advanced users of PLATEIA and FERROVIA are with us today, which I am very happy about. I will try to do my best and make sure you will get some useful information by the end of the webinar. That's why you will see QR codes on your screen several times. If you scan them, you can find additional detailed instructions and more complex tutorials depending on the topic we are going to talk about. Today's webinar will be based on three main topics. The first topic is the creation of a digital terrain model. We will discuss which options are available to the user in the PLATEIA and FERROVIA software, and then I will show you some examples directly in the program. After that, we will continue with a typical design workflow, which I will show in the PLATEIA. We will quickly create an alignment, profile, and cross-sections. For the cross-sections, we will take more time and really look in detail at what we need to pay attention to in order to get a quality quantity takeoff and a 3D model. However, we must be aware that the designing workflow in PLATEIA is the same as in the FERROVIA program, which is used for railway designing, except that there we calculate the cant instead of the super elevation. Finally, we will look at the creation of a BIM model and export it to IFC. So let's get started. CGS Labs software solutions offer many different options for creating terrain. The user can work with AutoCAD, Civil 3D, BricsCAD, and CGS Lab surfaces, point clouds, and also project directly to native 3D faces and CGS Labs points. In short, no limits. The only important thing is to be aware of which platform you have the PLATEIA or FERROVIA program installed on. The platforms we support are Autodesk AutoCAD, Autodesk Civil 3D, and BricsCAD. And if you have CGS Lab software installed on Civil 3D, in this case, you cannot project to BricsCAD surface and vice versa. As already mentioned, a designer can also use point clouds. A point cloud is essentially a huge collection of individual points plotted in a 3D space. It's made up of multitudes of points, usually captured using a 3D laser scanner or drone. The process of creating a surface from a point cloud is slightly different when using Autodesk Civil 3D compared to BricsCAD, so we have prepared two tutorials on our knowledge base. If you are interested, please scan this QR code and download the instructions. On the CGS Labs knowledge base, you can also find other tutorials, both simple and complex. In addition to the possibilities I just mentioned, last year we also developed so-called external reference surfaces. This functionality enables you to drape alignments, points, polylines, and other entities supported by CGS Labs Software Solutions to surfaces that are stored in external DWG files. This preserves a small amount of data in the design, drawing, and thus better manageability, faster drawing manipulation, and production of a small final drawings with all necessary design elements. The profile, cross sections, polyline, projected to surface, and more. At this point, I kindly invite you to answer one question that will appear on the screen. We would like to know which digital terrain you use the most. Given that the question is really easy, we would now close the survey and continue. Thank you to everyone who participated. Now let's start with today's example. Our first goal is to drape the alignment to 3 different terrains. In order not to waste too much time, we will start with a drawing in which we already have one terrain that is made with the Civil 3D software, since today we will work on the Civil 3D platform. But if we were in BricsCAD, we would start with the BricsCAD surface. The second terrain will be created using the CGS Labs tools to insert points from a file and create digital terrain model. The third terrain will be saved in the external DWG drawing, which means we will use the new external reference surface functionality. You can now see on your screen that I have an open DWG drawing in which I have terrain 1. I will now show you how to add the second terrain by using CGS Labs commands. First, you click on the Layout tab and run the Input Points from File command. It opens a new dialog box where you define the file with points and set which data should be imported into the drawing. On the top of the dialog box, you click the folder icon and find the file with points. You select the file and press Open. Then you click on the pencil icon, which opens a new dialog box where you set which columns contain which data. You press plus button to define a new file type name. After that, you press OK and define the extension and delimiter. Then it is necessary to define which column in the XYZ file represents which data. On the screen, you can now also see the XYZ file opened in Notepad. You can see that in the first column, there is information about the X coordinate, in the second column about the Y coordinate, and then there is a column with information about the elevation. Then you define the point type. Since we don't have this information in the XYZ file, I choose option constant from the drop-down menu. And then I select one of the default point types that are already in the program. If you wanted, you could also define your own point type with custom attributes, for example, point type with custom symbol, text height, etc. You can then define the point name. In our case, we will choose the option for the program to number the points itself. Alternatively, I can select the no data option and the command will still insert all the points in the drawing, but the name of all points will be 0. We have no information on the other attributes, so we select the no data option. After that, I will press the OK button. And then I will select newly defined file type name from the drop-down menu. And if I have everything correctly, the data from the file will be automatically displayed in the table. If you want the points to be drawn on a special layer, then you can check the box at the select layer and type a name. You can also select a predefined layer from the drop-down menu. Then you specify other parameters, for example, number of decimal points, and then press OK. Points are now inserted in the drawing. Since these are CGS lab points, we could already project alignment onto it, but we will also quickly create a digital terrain model. But before we move on to creating a digital terrain model, I want to show you another great tool. For many years, our solutions only supported the export of points to XYZ file. In the past year, we also developed the possibility of exporting points directly to an Excel file with one click. So you do this with the points report command. So you select this command, and then you select all the points in the drawing. And then press enter. You can then write these points in the current drawing table or export them to an Excel file. At the top, you also have an option for additional settings. So if your points have additional attributes, you can also export this data, which is really simple and very useful. So I just define the file name, press save, and then it opens the Excel. So very simple and very useful. Now we will create terrain based on these inserted points. So I run the terrain command and I define a surface name. Since the input data in the drawing is elevation points, you select points and break lines option from the drop-down menu. Then I click plus button and I select all the points in the drawing and press enter. Next, you need to choose how to display the terrain in the drawing. There are several different ways available. If you do not select any option and confirm it by clicking OK, the drawing won't change, but the software will remember the terrain and use it to draw the profile and cross sections. To show the terrain as triangulated irregular network, then click again on the terrain icon and then check the triangles box at the bottom of the dialog box and press OK. Now that we have two surfaces in the drawing, I can quickly show you how easily you can calculate the volume between them. So in the Site Design tab, you can find the surface volume command. After starting the command, you select the first and then the second terrain. After that, the values are displayed in the command line. It's more than just a new command. It's especially useful for quickly calculating cut and fill volumes. For example, after drawing a profile, draw 3D edges and the surfaces between them, and then use this tool to calculate volumes. Let's now look at the third terrain. This is again CGS Lab surface, except saved in a separate drawing. So it is not in the same drawing as terrain 1 and terrain 2. So first I will show you this terrain. And okay, if I move to a 3D view, you can see that this is a typical digital terrain model. I will now close this drawing because otherwise we will not be able to project onto this terrain. Now that we have all three terrains ready, I will quickly draw the alignment. I will use a read alignment option because I already prepared the axis. After running the command, pay attention to which terrain you choose from the drop-down menu. This will be your main terrain on which the alignment will be automatically projected. So in our case, this is the terrain 1. Besides a read alignment method, you have many other methods for drawing alignments, such as tangent polygon, floating elements, stick method, best fit analysis, and others. So this is so many options for creating an alignment, and after you create it, you then draw sample lines. Now we have an alignment and sample lines that are draped to basic terrain, in our case terrain 1. Since we want to show terrain 2 and terrain 3 in the profile and cross sections, we must first drape the alignment on these terrains. We do that very quickly and easily. So on the Layout tab, click the Drape command. It opens a new dialog box where you select a second surface on which you want the axis to be projected. In our case, terrain 2. So I select this terrain in this list, and then I confirm by pressing the OK button. Then you do this the same to the third terrain, and if you have even more terrains in the drawing, then you can repeat this procedure for other terrains. So I run the drape command again. This time I will click on the folder icon on the top of the dialog box because I will drape on the terrain that is not in this drawing. I remind you again that the drawing with the surface you want to drape on must not be open because it will give you an error and the projection will not be performed. So click on this folder icon, and after that it opens a new dialog box where you click the plus button and find the drawing with the terrain. Select it and press open. Then you press OK, and you can see that terrain is now displayed in the list of surfaces in the drawing. You can notice that the surface also gets a suffix which represents the name of the drawing. So I select this surface and click OK. If I zoom in on the drawing now, you can see that we have triple sample lines. To make it easier for you to imagine, I will change the layer color. So the green sample lines represents the projection onto terrain 3. The pink sample lines represents the projection onto terrain 2, and the blue sample lines are those that were automatically projected onto the base terrain that we defined in the alignment manager. So in our case, the terrain 1. Now, these terrains can be shown in the profile and then also in the cross sections. So I will now zoom out that you will see the whole drawing. So let's start with the profile. You click on the profile tab and run the profile view command and enter the parameters according to the established procedure. At the top of the dialog box, you select the table type, define the scale, and input data. Then select the surface from the drop-down menu. So if you click on the arrow, you can see the list of all terrains that the alignment is draped to. The first surface in the list is named 0. Don't let that distract you. This is the main terrain that you initially defined for the axis in the alignment manager. So in our case example, this is terrain 1. You select it, and then you can also define other parameters in these dialogues, and after that you press the OK button. Next, you define the location of the profile view in the drawing. Okay, now you have a profile view with one basic terrain, and I guess you might be wondering how to insert other terrains. You simply click the Draw Profile command again, and this time select terrain 2 from the drop-down menu and click OK. You can see that the terrain 2 is now inserted into the drawing. After that, you repeat the procedure for the terrain 3. Okay, all three terrains are now displayed in the profile view. You can then proceed with drawing a profile and calculate super elevations. We would not delve too deeply into these matters today in this webinar. I will just draw one simple profile. If you are a new user, I invite you to visit our CGS Labs Academy website, where you'll find basic trainings for PLATEIA and FERROVIA. In addition to videos, these trainings also have DWG drawings and PDF instructions, so you can repeat the procedures yourself and quickly learn the workflow. But if you are more advanced user and you are interested in more specific things, you can find them on our knowledge base or contact our support team. Support is provided by experienced engineers who are also certified civil engineers, and I am sure that they can handle any problem, no matter the complexity. So that you have all the links in one place, we are now also sending you a handout. I think that you should get a message on your screen that you can download the document. Now you continue with cross sections. First, you insert cross sections view. You click the cross section tab and run the draw cross section command. Choose the PLATEIA table type from the drop-down menu and select current drawing for the input files. After that, select the main surface. As we saw earlier, it is called 0. Then you define also other parameters and click OK. After that, define the insertion point. Next, you insert the second terrain in the same way as in the profile. So you run the draw cross-section view again, and then select the second terrain. Press OK. But before we insert the third terrain, I will show you one trick. So if you run the edit table command, you can define a new rubric that will be shown in the table below the cross sections. Once you have defined the name, it is important to save it. So click on the Save button and type the table name. Next, confirm parameters by clicking the OK button. Then you run the Draw Cross-Section View command again and select Terrain Free from the drop-down menu. Then click on the Settings icon and check the box of the Elevation option and select Previously Defined Rubric from the drop-down menu. Confirm parameters by pressing the OK button. And okay. If I zoom in to the, for example, to the first cross section, you can see we have now 3 terrains inserted in the cross section and a new rubric in which the elevation data of terrain are displayed. Now I will add typical cross-section elements. At this point, I would like to remind you once again that all elements must be planimetrified if you want to draw them as a 3D models and create quantity takeoff. So I will draw the normal cross-section with the help of macro, and then I will show you how to planimetrify the cuts of 3 different materials. If you don't happen to be the most skilled at drawing and editing cross sections, please check out the basic trainings at CGS Labs Academy. Now together we will planimetry cuts. So let's run the planimetry command. At the top of the dialog box, specify the method. The first method is called between cross section. In doing so, we define the first and last cross section, and planimetry will be carried out in this area. If you click on the tick button, the planimetry will be performed on all cross sections, but we can also choose a specific area. We have 2 options here. cross sections can be selected from the drop-down menu or click on the icon next to it and then find the profile directly in the drawing. Another very useful method, which is not often shown to the users, is the area. So you click plus button to define an area definition. First, you write down the area name and then the list of cross sections. You can write down the area or just the name of one profile, and you separate the different areas with the comma. This option is very useful as you can save quite a bit of time. So let's say that you don't need to draw a sidewalk along the whole alignment, but only in 3 areas. If you use this method, you will only draw the sidewalk once, whereas you would have to draw it 3 times if you use the between cross sections method. These area definitions are saved in the current drawing and can be then used in other commands for cross sections, for example, inserting typical cross section elements or macros. We are left with one more method called interactive. So after selecting this method, you define a new polygon directly in a cross section by picking points. When you completed a polygon, press enter and draw a new polygon in the next cross section. In this way, you can draw polygons in random cross sections. Okay, now let's look at the middle part of the dialogues box. In this part, you specify the type of planimetric quantity and the material. First on the list is the area option, as it is also the most frequently used. Please don't mind these numbers in parentheses. They are just a type designation, so they have no special meaning. After executing the command, a polygon and a hatch appear in the drawing, which are the basis for the later calculations of volumes. So when you define the type of the planimetric quantity, then you must select the material. And if you click on the settings icon, a list of all quantities appears. So you can then edit the existing quantities or add new ones. These quantities are written in PLA file, which you can also copy and share with co-workers. So after you select, then you select a material from the drop-down menu and define the planimetry polygon definition and additional settings. So the first option is inner point. In this case, you first select the line that represents the edge. And then press enter, and then after that, click inside the polygon. The second option is between 2 polylines. Using this method, you define 2 polygons lines bordering a surface you want to planimetry. So I select the type of a planimetry, again, a material. This time I will select between 2 polylines and under reference polylines. So if you select under reference polyline, you first click on the upper edge of the material, press enter, and then click on the remaining lines, which represents the boundary of the polygon. If you selected the under reference polyline, then always be sure to click lines in a counterclockwise direction. Another type of planimetric quantity is length. The length is used for materials such as geosynthetics, geocomposites, geogrids, and embankment protections such as, for example, nets, vegetations, and life support structure. After that, you, of course, select a material and then a planimetry polygon definition. I select typical cross-section element set option, and that means that I can then select several lines in the drawing and the program will generate a new one based on the selected lines. When you then do the quantity takeoff, the result is the area. The third option is length times thickness. This is used for humus in cut or fill. It is very similar to the previous option, except that you also enter the thickness. So you select the planimetric quantity, the material, definition, and you define the thickness. This thickness serves only as input data for the quantity takeoff and is not displayed in cross sections. The display in cross sections is the same as in the previous method. In other words, as a thickened line. So you select all the lines and then you press enter. If you want, you can also planimetry the quantities on the left and right side. Okay. If you want, you can also planimetry the quantities, on the left and right side of the cut. To do this, you have to draw additional lines, since you can only planimetry closed polygons. This means that you draw 2 additional lines on the left and right. The easiest way is to use the typical cross-section line element. At this point, I would also like to give you an advice. If the same planimetric quantities touch each other, it is better to name them differently. For example, cut one right, and cut one left. This is a better approach to creating a 3D model. Before we continue, I would like to show you one more very useful command, which is verify polygons. This command automatically checks and deletes duplicated planimetric quantities. I recommend them doing this before running the quantity takeoff and draw 3D model command. Due to duplicate quantities, you may have incorrect total quantities and duplicate solids. There is another very useful tool under the verify polygons command. It's called turn area on and off. After running the command, a list of all materials in cross sections is displayed. By clicking on the light, you can then hide materials in cross sections. For example, this is very useful when the cut overlaps other materials. When you have planimetrified all the quantities, you can create a quantity takeoff and a 3D model. So you run the quantity takeoff command. And here again, you select a method on the top of the dialog box. And in the middle part, you can define how the quantities should be shown by profiles. So you can check the insert in drawing option. So you click this box at the insert in drawing and then select the location for planimetry labels. You also have the option to save them to an external file. In the lower part, you choose the method and define where in the drawing the table with the quantity summary should be drawn. There are 3 methods available for calculation. The standard method calculates the volume of a formula written in the help document, where d is the distance between 2 cross sections. In the L-link method, however, d represents the distance between centroids of planimetry areas between 2 cross sections. Therefore, the method is more accurate than the standard one because it respects the position of the root axis in 3D space. Due to the fact that horizontal alignment is considered, it is necessary to define the layout drawing even if it is in the current drawing. I select the standard method and then I check the box at insert in drawing option. And I define the location for quantity table. Okay, next I press OK. And now the table will be inserted into the drawing. And at the same time, Also the quantities are written out in each individual cross section. So if I zoom in one cross section, you can see the names, the name of quantities and values. I recommend you using a typical cross-section element manager tool to view cross sections. So after running the command, a modeless dialog box opens, which stay open while you are able to work with other tools. So you can zoom into a specific cross section in the list by simply clicking on it, or use arrow keys to move up or down in the list and select any cross sections. You can select one. You can also select one of predefined criteria from the drop-down menu. Besides, you can select custom option from the drop-down list. And you then draw a rectangle around the cross section. And when the rectangle is drawn, the software automatically zooms in this area. If you click on the element view, a list of all elements appears, and if you select one element, it is then marked in all cross sections. After editing and inspecting all cross sections, you can create a 3D model. But since we want to make a BIM model, we will first define property sets. In CGS Labs Solutions, the user has two options: automatic attributes, which values are calculated and inserted automatically after drawing a model with the Draw 3D Model command, and attributes that are defined and attached manually. In addition, it has a tool for viewing and editing attribute values. Let's take a look at this process of editing property sets. So first, we need to define property sets in the Property Manager. To add a new property set, click on the plus button and define the name. Then we will add attributes. Define a name and select and then select property type from the drop-down menu. If you choose the user-defined option, it means that you will have to enter the attributes values manually. We enter the default value in cases where we know that it will always be the same. In other cases, we prefer to enter it manually using the property set editor command. If you choose one of other options for property type, the program will automatically insert the volume of the attribute after we run the Draw 3D Model command. Information about which attributes you needed to attach to an individual model can be found in the BIM execution plan. So I click on the plus button, I define the name of the attribute, and if I want that it will be, if I want that the value will be inserted automatically, then I select a property time, in this case start station, and now I want that it also calculate automatically the end station for the element. And the last one is axis. Okay. Once you have defined all the property sets and arranged the cross sections, you can create a BIM model. After running the Draw 3D Model command, define source data, alignment, and select quantities. Then define the corresponding property set for each quantity. For example, base coarse property set for the element base. Then check the box at the Align option to connect the consecutive planimetry polygons along the alignment. Otherwise, it connects the adjacent planimetry polygons with sectional straight lines. After pressing the OK button, a BIM model is inserted in the drawing. Okay, so you can see this is my BIM model, so a 3D model with attached information. With the help of the property set editor tool, you can then check property sets. So first I will hide the upper layers of the CAD so that we will better see the model. For that I will use basic CAD functionalities. So I select elements and then right click to find the hide entities command. You can select you can click on individual elements, on individual solids, or you can click on one solid and then select the option, select similar, and all the elements will be selected. Okay, now I will run the property set editor command. And I will select one element in the drawing. You can also select all the elements that are surface course type. And you can see that some attributes, some values of the attributes were inserted automatically. And with this tool, you can also add more property sets to one or more elements. For example, a property set with project data. And you can also type new values, or you can also edit existing values of attributes. Once you have created the entire model and equipped it with attributes, you can create different renders or construction simulations based on it. To be able to open the model from CGS Labs Software Solutions in another program, you can export the completed model to IFC. We have now reached the end of the webinar. To quickly recap today's key steps were creating digital terrain models, draping alignment to different terrains, inserting terrains into the profile view, creating the profile and calculating super elevation, inserting terrain in cross sections, making typical cross section elements and planimetry, and finally the creation of BIM model. To sum up, I would like to invite you to follow our LinkedIn profile. To do so, please scan this QR code or click on the link in the chat. That way, you can always be informed about new webinars, tutorials, and successful stories of our customers. I hope that you learned something new in today's webinar and that this knowledge will help you in your work. Therefore, I conclude today's lecture with a wonderful thought by the playwright Anton Chekhov. Knowledge is of no value unless you put it into practice. Thank you for the attention. Now I will hand the floor back to Gregor.
Thank you, Petra, for this great in-depth presentation. Just let me switch my screen. Okay. Now you have seen quite some functionality from PLATEIA and FERROVIA, and in case you would like to try our software, if you didn't do that yet, I would like to let you know that we offer free 14-day trial for each of our products. Our products are in trial mode, are fully functional with no technical limitations. Upon that, we provide you with live customer support during your trial period. This was also mentioned by Petra already. We offer knowledge base to help you out during your trial, and also, of course, if you're already a user of our software. Again, there are free basic online trainings available for each of our product. In focus products are PLATEIA and FERROVIA. These are some very good video tutorials with all the DVGs that you need and PDFs that need to support you, and you can really go step by step through the functionality and to get you started. Now I would like just to check if there are any questions. I think we have a couple of them, and I would kindly ask Petra if she can answer, because I think there are technical questions.
Yes, I can see one question, and the question is: Are these AutoCAD solids? So yeah, when we create a 3D model, these elements are AutoCAD solids, and there was a question if the user can access to them. I guess that if the user wants this completed drawing, that we can send him after this webinar. So this is all.
Okay. So I would like to really thank you for today. I would like to again invite you to visit our other webinars that are in our system. We launched in the past several targeted webinars for road designers, railway designers, and they are really comprehensive webinars, and you can access them for free in case you don't know. I would like to remind you again that we uploaded a handout in the system. You can find it in the handout section, and it includes all the links to our resources that you might find useful. Again, webinars, we have a blog, knowledge base, YouTube channel, and so on. You can find all the information needed, but nevertheless, if you have any questions, don't hesitate to contact us, or if you have a partner in your country, you can contact a partner or our direct office in your country. So I would like to really thank you again for today and for your attention, and we really hope to see you in one of our next webinars. I think we have one planned already for next month, and we will notify you in the timely manner. So looking forward to meet with you again. Thank you for today, and goodbye.